Hi children, hello, welcome to your home school. This is your class 9 mathematics NCERT or CBSE board. We are in our 5th chapter, triangles. In this session, we are going to deal about theorems. Theorem 5.2. What is the statement? Angles opposite to equal sides of an isosceles triangle are equal. Let us draw an isosceles triangle. What is isosceles triangle? Two sides are equal. A, B, C. How can we prove this theorem? This can be proved in many ways. One of the method we are going to prove this. Let us start your theorem. How can we start, children? Data. What is given in this? Given a triangle. But I am going to consider a triangle ABC. Given triangle ABC is an isosceles triangle where AB equal to AC. Okay. Next, I am going to take a construction here. I am going to draw a construction. What I am going to do here? Draw angular bisector. Angular bisector means what, children? It divides the angle equally. Draw angular bisector from angle A. Draw angular bisector from angle A. It divides. What it makes, children? Angle BAD is equal to angle DAC. To prove, what we need to prove here? To prove that angle B is equal to angle C, I need to prove. Given an isosceles triangle, angles opposite to equal side. See children, these two are equal sides. For this side, what is opposite angle? And for this side, what is opposite angle B? These two opposite angles are equal. We need to prove. That means angle B equal to angle C. Proof. We know that consider triangle ABD and triangle ACD. Now compare these two triangles, children. Orally just say this side equal to this side, and this is a common side for both the triangles, and this is angles are equal. According to the construction, these angles are equal. Then these two triangles will be congruent. If they are congruent, the corresponding angles are equal. That is only our proof. Consider triangle ABD and triangle ACD. AB is equal to AC. How? That is the given data. And angle BAD is equal to angle DAC. How can we say this? By construction. By construction, through the angular bisector, these two angles are equal. AD is equal to AD. AD equal to AD means this is a common side for two triangles. Therefore, triangle ABD is congruent to triangle ACD. If they are congruent, what you can write here, children? Corresponding angles of a congruent triangles are equal. Corresponding angle of a congruent triangles are equal. Therefore, angle B is equal to angle C. Finally, what you can say? Opposite angles to the equal sides. Opposite angles to equal sides of an isosceles triangle are equal. Hence it is proved. That's it, children. Very small tiny theorem. So sides equal, prove that angles equal. How can we prove? Take a triangle, do a angular bisector. It divides into equal angles. Sides are equal, angles equal, and this side is common. By how you are seeing this congruency, children? SAS rule. What do you mean by SAS? Side angle side rule. I can say that the two triangles are congruent. If they are congruent, the corresponding angles of a congruent triangles are equal. Therefore, angle B equal to angle C. That's it. 5.3. What is the statement? The sides opposite to equal angles of a triangle are equal. Let me take one problem. This theorem also can be proved in many ways. The sides opposite to equal angles. Let me take a triangle ABC. They said equal angles. Let us take angle B equal to angle C. The sides opposite to equal angles means what? This angle opposite side is AC and this angle opposite side is AB. These two sides equal, we need to prove. How can I prove this one? So for that I need to take some problem. This theorem can be proved in many ways, we know. So any one problem I'll take here in order to prove this. Let me take a perpendicular which is exactly dividing at the midpoint of the base. Perpendicular D. If D is the midpoint of the base BC, what you can say, children? This side equal to this side. Then this is right angle. Perpendicular means right angle. And this is right angle. So observe here carefully. Angle, side, angle of this triangle is equal to angle, side, angle of other triangle. Therefore, by ASA rule, I can say that two triangles are congruent. If they are congruent, by CPCT, corresponding sides are equal. Let's start our proof by data. In triangle ABC, they have given angles equal, right? Angle B equal to angle C. What we need to prove? To prove AB is equal to AC. I am going to do a construction. What is that construction? Draw a perpendicular. Draw a perpendicular from A to D such that it divides BC at midpoint. It divides BC at midpoint. So I have drawn a construction in such a way, and that is AD is perpendicular to BC. Draw a line, draw a perpendicular from A to D such that it divides the base at a midpoint. Divides BC at midpoint. Now, let's start our proof. Consider triangle ABD and triangle ADC. So, compare these two triangles, children. Angle B equal to angle C. How? It is given. Then I say that BD equal to DC. How? By construction. Then angle BDA is equal to angle CDA. This is also through the construction. Therefore, triangle ABD is congruent to triangle ADC. By which rule, children? Angle, side, angle, side, angle. That is ASA rule. I say that these two are congruent. If they are congruent, by CT, I can equate the other sides, that is AB equal to AC. Hence, it is proved. What it is proved, children? If two angles of a triangle are equal, prove that their opposite sides are equal. For that, what we have done? We have taken a triangle and we have done a perpendicular, two angles equal given. So, perpendicular, what does it do? It divides at the midpoint of opposite base. Then these two sides are equal and perpendicular both are 90 degrees. Angle, side, angle, I can say that the two triangles are congruent. If they are congruent, you can equate the corresponding parts of a congruent triangles. Exercise 5.2, first problem. In an isosceles triangle ABC. What do you mean by isosceles? Two sides are equal. Let me take a triangle ABC where AB equal to AC. Isosceles triangle ABC where AB equal to AC. The bisectors of angle B and angle C. Bisectors of angle B and angle C means what, children? The angular bisector, this angle equal to this angle and this angle equal to this angle. The angular bisectors of angle B and angle C intersect each other at O, join A to O, show that OB equal to OC. And AO is a bisector of angle A. How can we prove this one? First, let us discuss how can we prove. Given ABC is a isosceles triangle, AB equal to AC given. If these two sides are equal, what you can say, children? These two angles are equal. According to the theorem statement, do you remember now? Angle B equal to angle C. And they have said that it is angular bisector. The angle is cut into half. Angle B, angle C is divided. So this interior angle equal to this interior angle. And this angle equal to this angle. Angular bisector, right? So if these two angles of this small triangle, if these two angles are equal, by another theorem statement, what you can say, in a triangle, if two angles are equal, their opposite sides are equal. That is only the first proof. OB equal to OC, we got it. Right? Second one, how can I prove that? AO bisects angle A. Bisects angle A means this angle must be equal to this angle. How can I prove that? By first question, I say these two sides are equal. Look here, children, this side equal to this side. When angular bisector is done at B and C, this angle is also equal to this angle now, right? By side, angle, side, side, angle, side. SA is congruency rule. I can say that these two triangles are congruent. If these two triangles are congruent, their angles are, by CPCT, I can equate these two angles. If this angle equal to this angle, I can say that angle A is bisected. That means AO bisects angle A. Let's start a proof here. Solution. Let's start the given data. Given ABC, triangle ABC is an isosceles triangle. Isosceles triangle where AB equal to AC. Ready? Now, what to prove? To prove, you can write the two statements at a time, children, like this, 1 and 2. One is OB equal to OC and the other is AO bisects angle A. Join AO. Proof. How do we start our proof, children? They have given it is an isosceles triangle, right? We know in triangle ABC, two sides are equal. AB equal to AC. We know by theorem. What we can say, children? We know by theorem. If two sides are equal, their opposite angles are equal. Angle B equal to angle C. What is angle B? I write it as angle ABC and angle BCA or ACB you can write, no problem. These two sides are equal, children, then the opposite angles are equal. That means AB side opposite is angle BCA and AC side opposite is angle ABC. That this side, or you can write anyway, no problem. Angle ABC is equal to angle BCA. Now, what is half of this? Half of angle ABC is equal to half of angle BCA. Half of angle ABC, when I say, either this part you can take or this part you can take. Your wish. Now next I am going to consider this triangle, right? So I take only this part. Observe here, children, carefully. This part I am going to take. Half of angle ABC, I write it as angle OBC. And half of angle BCA, I need this triangle inside part, that is BCO. Angle BCO. Now, your first proof will be started here. What is that, children? OBC is equal to angle BCO. In triangle, now in triangle OBC, children, what did I do? I just consider only this triangle. What I got from above, I can say angle OBC is equal to angle BCO. We know by theorem. We know by theorem. What do we know, children? If two angles of a triangle are equal, their opposite sides are equal. That is, OB is equal to OC. By above theorem, I am saying this statement. Now, in this triangle, if these two angles are equal, then their opposite sides are equal. That is, OB equal to OC. This is your first proof, children. Prove that OB equal to OC. Therefore, OB equal to OC. This is your first proof. If you want, you can write here from first like this. Second proof will be started here. How can I start second proof? Consider the triangle in triangle AOB and triangle AOC. See, children, this triangle and this triangle. Now, by above, what did I say? OB is equal to OC. Okay? And in triangle AOB and AOC, given AB is equal to AC. Given. This is already given in your question. And next, I say that angle ABO is equal to angle ACO. How, children? Half of this set. Angle ABC is equal to angle BCA. Half of this, I can say either this equal to this or this equal to this. Right? Now, I can say angle ABO is equal to angle ACO. Already it is proved above. Next one. OB equal to OC. OB equal to OC. This one also proved, children, above. Therefore, what you can say here? Side angle side. Side angle side. Therefore, triangle AOB is congruent to triangle AOC. By what congruency rule? Side angle side rule. I say that these two triangles are congruent. Therefore, by corresponding angles of a congruent triangles, corresponding angles of a congruent triangles, you can equate, children. So, I can say that angle BAO is equal to angle CAO. That means, therefore, angle A is a bisector. Angle A is a bisector. Therefore, finally you can say AO bisects angle A. Angle A is a bisector. When it comes this angle equal to this angle, you were able to say, then this angle is a bisector. That means AO line, AO is a bisector of angle A. That's all. That is only the thing we need to prove. See the second problem. In triangle ABC, AD is perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB equal to AC. Similar type we have done in theorem, children. So this is a little different from that. Now, if AD is a bisector, if it is a perpendicular bisector, then what does it do, children? It divides at the midpoint. That means BD equal to DC. And the perpendicular, this angle is 90 and this angle will be 90. Then AD is a common side for two triangles. Therefore, by side angle side and side angle side, SA's congruency rule, I can say that the two triangles are congruent. If they are congruent by CPCT, I can equate other two sides equal. If those two sides equal, then it becomes an isosceles triangle. Let's start here. Solution. Given. First write the data. Given triangle ABC, given in triangle ABC, AD is perpendicular bisector. AD is perpendicular bisector of BC. Perpendicular bisector of BC. Show that. To prove. What to prove, children? Triangle ABC is an isosceles triangle. You need to prove that. Right? Let's start our proof. How can we start here, children? Consider or in triangle ABD and triangle ACD. Start comparing here. When this AD perpendicularly drawn, then I can say BD equal to DC. Given by construction, already given perpendicular means it is at the exactly dividing at the midpoint, that is BD equal to DC. Then angle BDA is equal to angle CDA is equal to 90 degrees. This is also by given data, perpendicular given, no, that is also given, you can write. And next one, AD of this triangle is equal to AD of another triangle, you can write it as common. Therefore triangle ABD is congruent to triangle ACD. By which rule, children? Side angle side. Yes, AS congruency rule. I say that the two triangles are congruent. If they are congruent, by CPCT, what I can say? Other corresponding parts you can equate. That is AB equal to AC. Therefore, triangle ABC. Now, AB equal to AC, if I say that, what happens, children? It becomes a isosceles triangle. Therefore, triangle ABC is a isosceles triangle. Hence, it is proved. That's all. We need to prove only this much. Right? Compare the triangles carefully and apply the rule. By CPCT, remaining sides and remaining angles are equal. Okay, children, with this, we are going to end our session today. In our next session, we are going to complete our next exercise. Until that, keep watching. Thank you all.